Hi everyone, my name is MarkO'Sullivan. I'm the CEO of NeuroBell. It's a medical device startup based out of Cork in Ireland. I'm going to be talking to you today about our work in the space of neonatal seizure detection and developing AI models and portable EEG monitoring. Two disclosures, I'm obviously Irish and also an engineer, so I'm not sure which is worse. There's 140 million births globally each year, and unfortunately it's suspected that up to 2 million infants suffer brain injury during or soon after birth. Seizures are the most common manifestation of brain injury in neonates and require urgent treatment to try and reduce the total seizure burden and ideally end up with better outcomes for these newborns. It's been shown in many studies that 66% of neonatal seizures are subclinical, meaning that they present no clinical or visual signs. An analogy often used is that the seizures that you can see are the tip of the iceberg, that there's many more subclinical seizures may have happened up until that point. So detecting these seizures are very difficult. Continuous multi-channel EEG monitoring is the gold standard for reliably detecting all neonatal seizures. However, it requires complex equipment, it's a timely process, and it requires specialist staff that often aren't available immediately to the NICU. That presents a big challenge. AEG is obviously a great tool for using in the absence of multi-channel EEG. However, studies from Janet Rennie and others have shown that it can miss up to 50% of seizures. The International League Against Epilepsy, they provided a report in 2021 stating that AEG confirmation of a seizure only provides a possible diagnosis, and the absence of seizures in the AEG is not sufficient evidence for ruling out seizures. That shows why, I suppose, multi-channel EEG is so important. And other studies have shown the importance of treating seizures early. So between Cork and Toronto, there's studies that have shown treating seizures early, firstly, reduce the overall seizure burden. Not treating seizures can lead to drug-resistant seizures. And also, there's been studies showing that a neonate who suffers more than 40 minutes of total seizure burden in the neonatal period has, regardless of the underlying condition, has an independently associated outcome with poor neurodevelopmental outcome. But that's why trying to get these neonates on EEG as soon as possible is so important. Our team with NeuroBell have been developing the NeuroBell Luna system for the bones of 8 years at this stage. It's an 8-channel, pocket-sized and wireless EEG monitor that offers AI insights. It's a system that basically has a 2-button interface. Press the power button, press the record button. Automatically, the AI model starts running on the device and provides updates continuously. And if there is a seizure detected, it will flash at the bedside. So the bedside team are the first team to get the alerts when a seizure is present. We've done studies to show that it can be used by all NICU staff in under 10 minutes. This is what it looks like in practice. So that's the system. It can be mounted to any bedside pole or rail or incubator. We've done studies actually using it in transport as well. So we did our first feasibility study showing that putting this into an emergency transport situation, the clinician was able to apply all the 10 leads in under 9 minutes, and then we continued the recording and looked at the data quality while flying down a highway at 60 miles an hour versus stationary, and we presented that work at the International Newborn Brain Conference earlier this year. In addition to the device itself, we have a software system, so all the data gets streamed over Wi-Fi to our cloud platform. This device, or this system here, can be accessed from any web browser using your existing hospital single sign-on service. So this means that you can pull it up on your phone, your tablet, your laptop. You can log in. This is the output of the seizure trend, so you can look at that over time. That shows you your places where seizures likely happened. And then you're also able to click into the raw data. So in particular, if the neurology team wants to report on it, they can click in, start playing back the EEG. If they spot something that they want to annotate, they can pause the recording, annotate. It goes directly into the EDF file. And I guess our overall aim here is to try and help the reporting process as well. So it should be the first system that can be applied by the NICU team as well as reported on by the neurology team, as it doesn't move away from any of their existing CPT billing codes either. So that's the system for the software side, both usable by the NICU team as well as the neurology team. And I'm just going to step into some of the machine learning side. So our Chief Scientific Officer, Alison O'Shea, she did her PhD in the Infant Centre as well. She developed the first deep learning model for neonatal seizure detection. That model has been trained and tested on over 5,000 hours of neonatal EEG. We had that data annotated by 3 expert neurologists, including Dr. Bob Clancy as a US-based annotator, and then we take the majority vote between those 3 annotators as the ground truth for the system. So I suppose our current results show that we can detect 85% of all neonatal seizures with a false positive rate of 0.3 per hour. By comparison, the Olympic Brains Monitor, which is our predicate device, can detect 61% of seizures, and it provides a false detection rate of 0.5 per hour. So in that plot on the right-hand side, just to dig into a bit more, you can see this green box, and that green box basically is the inter-rater agreement between our 3 neurologists. So what that means is we took the majority vote between the 3 of them, which is, let's say, our ground truth and our 100% seizure detection. And then that green box is the inter-rater disagreement, or I suppose variability, between how they rated. So between the raters, they were able to detect 65 to 90% of seizures, and their false detection rate was between 0.4 to 1.6. So our aim with NeuroBell was to be either at the top end of that inter-rater agreement, or else actually performing better than an individual neurologist as a rater. So we've managed to achieve that at this stage, and filing with the FDA later this year. But using AI-driven seizure detection also allows us to make better insights in terms of visualizing this and providing better clinical insights. So these plots here are heat maps driven by our AI model. So probably difficult to see, but those circles are meant to represent a neonate's head, and you can see a little triangle at the top. And that's basically your orientation. And then we can use our AI model to tell you which channels were activated during the seizure detection. So you can see in that first plot on the top left that the blue means that the heat map is low, so there was very low probability of seizure. In the top right corner, you can see a seizure that's high probability in the CZ and PZ region. And building on this, we were able to look at this and move it across time. So that's what this happened or creates here. So we have a 15-minute EEG that's taken a heat map driven by our AI model, and then we can look at that over time. So we've taken a 15-minute EEG, compressed that into a 15-minute heat map, and you can see how seizures evolve. So that red section you see there is a seizure happening over time, and you can look at how it progresses. And I suppose our overall aim here is to try and help provide better reporting tools, and eventually it should hopefully enable the neurology departments also to provide quicker and more insightful reports to the NICU team in a more timely manner. So we're currently in clinical trials in Ireland and the US. We have studies running in Cork and Indiana, which are prospectively recruiting neonates with brain injury, demonstrating the equivalence of our EEG system to a conventional system, and then retrospectively demonstrating how our device would have intervened had the seizure detection algorithm been implemented and clinically used. We received funding in addition to that from Baylor College of Medicine to conduct a study with Texas Children's Hospital, which is actually trying to recruit infants as soon as they come out of congenital heart defect surgery and try and get an EEG on within the first 2 or 3 hours. There's, I suppose, a research benefit here as well as a commercial benefit, but the research benefit is we don't fully know with these neonates, which ones of those will have seizures. So there's an important piece there in terms of characterizing these neonates for seizure burden, but also the American Clinical Neurophysiology Society guidelines, the ACNS guidelines, recommends that all neonates post-operatively should have an EEG. So it's demonstrating that with a portable-based EEG system, how easy that is to actually implement on all these neonates coming out of surgery. So there are ongoing studies. We're actively looking for new pilot sites and new partners to conduct new studies, in particular looking at a multi-center study here in the US, which is going to look at assessing outcomes. So implementing our device clinically, what's the reduced seizure burden, what's the total outcome in terms of reducing seizure burden, and then looking long-term at what were the benefits for these patients. And in addition to that, we're always conducting new research, looking at where EEG can be clinically useful. So looking at things like pain management, sleep analysis, motor development, anywhere where we think there's an avenue that EEG could be clinically or prognostically of benefit. So actively seeking new partners, and I hopefully encourage anyone who's interested to come talk to us. We do have a booth over in the Hyatt. Unfortunately, British Airways decided to lose our bags on the way over. So we're without our demos, but they're due to arrive in the morning. So yeah, there's probably a joke there somewhere about the British sabotaging the Irish again, but we'll leave that for next time. Thanks, Moon.